This is going to be a little demonstration of two types of earthquake waves that travel through the crust. Okay, so they happen at the bottom, near the bottom or down in the crust, at a point quite deep called the focus. So that's underneath the surface. Directly above the focus, so where buildings and everything are, would be called the epicenter. So you might have heard of the epicenter of an earthquake. That's the point on the earth where the earthquake is said to be centered. It's not really a center, that's why it's because the center is really the focus, where all the energy is released. So that's why it's called an epicenter, not the center. All right, so this is directly above the earthquake. This is where the earthquake actually happens, down here. The waves that go through the crust are called are called body waves. They make the whole body of that bit of the crust move, not just bits of it, the whole lot does. And there's two types, primary or P waves, which not surprisingly hit first, and S or secondary waves, which hit second. But they have different types of movement, which is why they cause different types of damage and why they travel at different speeds. This is the first time I've tried this demo, so let's hope it actually does show something. The pressure wave, the primary wave, moves the earth this way. Okay, and I'm not doing it hard enough yet to make any movement, so this would be just a very gentle wave. And we can see the wave front, the energy of the wave is going up and down, like this. So if it was stronger, it makes a jolting up and down at the epicenter. Okay, so at the epicenter, everything moves up and down like that. All right, so to turn it 90 degrees, I'm sorry, it's quite close, but the wave goes this way and it pushes everything up and down. I think I might just move that back a little bit so we can see it better. So the pressure goes through, compressing and then expanding the particles, and then it makes the earth go up and down a bit. So that's that jolt you often feel in an earthquake. It's that first boom, that loud bang sound at the start of a lot of big earthquakes. So that's your primary wave. It goes really fast because it's just compressing and expanding the particles. So it goes really fast to the surface. The next one, the secondary waves, are a little bit slower because of the type of movement. The wave front still goes this way. Now the wave front is just the direction of the wave, so it heads towards the surface. But it's a bit more like a water wave. The particles move side to side like this. And so let's see what effect this has on the building. Can you see it's rocking the building a little bit? So if we go 90 degrees again, the wave itself is doing this, which makes the earth do that. Okay? So we've got our primary wave, very fast, pushes things up and down. And then just after it, the secondary wave moving this way makes it rock a bit. Now neither of these are actually that damaging unless it's a massive earthquake. A little earthquake has a very small, what we call amplitude. It only moves a little bit, so you only get a little movement. Big earthquakes have huge amplitudes, and look, it broke itself off that. So it moves things side to side a lot. So the amount of energy in an earthquake, I'm just going to show this by getting someone to hold the end, please, is to do with a thing called amplitude. So a small amplitude P wave would look like this. A big amplitude, a lot of energy wave would look like this. And everyone who saw what I was doing, I was putting a lot more energy in with my arm. So big earthquake versus small earthquake. Secondary wave, this is what a small earthquake would look like. Small amplitude. And a big one, that. So you can imagine the amount of shaking up at the other end that it's being held. How do we measure how big an earthquake is? Richter scale, cool. So that tells us basically how much energy was in it. There's also a thing called the modified Mercalli scale, which is about intensity, which is basically how much it shakes things, how much damage it does, and they're both really good scales. Now, the last type of waves are our surface waves. So they don't hit at the epicenter, they hit to the side of it. And they travel along the surface. And these are the ones that really do damage. So they're called rally and love waves, R and L waves. And now I have to try and remember exactly how these go. I need a volunteer to hold the house there, okay? And let it go with the motion of the spring, please. The first motion is like this. So if you let it go with the motion of the spring, oh no, follow the motion. So when it pushes up, go up with it. Okay, and if we have a big earthquake, you can imagine how much damage that does after all that other shaking. These come next. And then you get rally waves, which really are like water waves. And they do this. They're in a circular motion like this. So the house basically gets thrown. The whole ground gets thrown up and along. Okay, so we'll do that again. You ready? Yep. So those are, I don't remember which way around they go. We'll have to check in our books for which one's the R and which one's the L. But they're your two surface waves, and they are really destructive. If they hit with any energy, with any amplitude, then they cause a lot of damage. And they caused a lot of damage, particularly in our February earthquake, because these ones bounce off mountains and hills and come back for a second shot. They reflect, which makes them really, really dangerous. So, just to summarise again, we'll get rid of the house. If I'm holding the focus, a primary wave would look like this, moving everything up and down at the surface. A secondary wave looks like this, which would make everything sway on the surface. And then, now I'm not the epicenter, now I'm not the focus, I'm the epicenter. As the surface waves go away from the epicenter, we have this happening, which is going to be really destructive because it's going to throw things up in the ground. And this sort of motion causing a lot of ground movement. All right, any questions on that before I stop the video?